Hey guys, welcome back. Today's video is a continuation of our series on data structures. Today's data structure is going to be linked lists. And what is a linked list? The best way to describe what a linked list is, in my opinion, is to start with an array. What is an array? So let's create an array. I'm going to call him my array, a variable called my array. So with arrays, at creation, once you create it, you have to define the size of the array. Let's create an array of 5 elements. And let's say he contains just because, let's say, even numbers, so 0, 2, 4, 6, and 8. Okay, let's go ahead and also write the indices. So this is index 0, index 1, index 2, 3, and 4. 5 elements. Okay, now what is the downside of arrays? The first of many is fixed size, meaning once you create this array and initialize its size, you cannot add to this array. To add to this array, you need to create a new one, a new copy of this array with an increased size. Okay, so fixed size is the first limitation. The second limitation is all elements in an array have to have the same data type, meaning I can't go in here and change this to a string A or anything, right? This is not allowed. This is going to cause an issue. So these are the two main limitations of arrays. Okay, but how can we build on this? Let me go back and change this back to 2, okay, because it's not allowed. So this led to what we call lists, and list is in most programming language, but mostly Python. So let's create an element called my list. So my list, at creation, you do not have to initialize his size, meaning you can add to him. For the scope of this lecture, let's ignore how the compiler, how the processor, how your operating system adds to a list. Let's just accept that you can add to him. So I can create a list, say, of even numbers 0, 2, 4, 6, 8, just like my array. And I can decide, hey, while I'm on my 8 guy, while I've already created this 8 guy, you know what, I want to make it have 6 elements, not 5, and I can go in and add a 10. For a list, this is completely valid. So it fixes the first issue of fixed size, and also same data type. I can go in here and say, hey, I don't want my list to only have integers, I want a string in there. So it also fixes the issue of same data type that limits the array. I can even say, hey, I want this guy not to be a string, he can be a more complex data structure like another list in there. List allow this, right? So this is what makes lists slightly better than arrays. But however, there's one downside of lists. Well, there's multiple obviously, but there's one main downside of lists, and it's if I want to kind of like I added this 10 in here to insert and delete in a list, you have to iterate through all the elements in the list. So you have to go from index 0, index 1, 2, 3, 4, just so we can insert 10 at index 5. In terms of big O analysis, that takes O of n insertion and deletion. So is there a data structure where we can do this in constant time? We can do this in big O of 1? And the answer is yes. And that data structure is called, yep, you guessed it, a linked list. To talk about a linked list, I first have to introduce what we call a node, because a node is the building block of a linked list. I'm gonna say my node, and a node is simply something like this. Consider a node like a box. Each box contains two things. The first thing it contains is data. This data can be an integer, can be a string, can be whatever, but that's the first thing it contains, data. The second thing it contains is the pointer to the next element. So there are two things a node mostly consists of. A linked list is just a combination of nodes. So let me create a variable called my linked list. My linked list is gonna look something like this. Now here's how I like to create my linked list, contrary to what most people do, right? The first node in my linked list is called the head node. But however, mine is slightly different because my head node always contains none. In other programming languages, it's called none. In Python, it's called none. So the data in my head node is none, and then he points to the second. Then the second node in my linked list is going to be whatever. Okay, so now let me append, and yeah, I use the word append. Let me add to the linked list. So my second element, let's say he's going to have a value of 0, kind of like our previous list had. Okay, and I'm just going to go on append into the linked list. The next element in the list is going to point to the next element in the list, point to the next element. This element right here, 0, points to the next one, and let's say the next one is A. Let's make him a string of A. Okay, then which points to the next one, which is 4, which points to the next one, 6, points to the next one, 8. However, our last element in the linked list always has to be none. He's not a node, he is just none. This is different than this element here. The first element is what we call our head. Again, some people don't have this element, some people don't have this, and they consider this the head. While I like to have a separate head that it always has a value of none. Today we're going to go through 4 basic operations on linked list. The first one is append, which is just pretty much how we build this linked list, starting from the head node, right? We appended each value. So append is pretty much just adding to the end of your linked list. Say for instance, we wanted to append a value of 10 to this linked list we have here. The first step to do is to create that node. Obviously, since it's going to have a value of 10, the data in that node is going to be 10. Now, what are we going to do with the pointer? So we're going to iterate through our linked list. And then once we get to the last guy whose pointer points to none, the last data whose pointer points to none, we break that pointer and point it to the node we want to append. Now, this new node, we take his next pointer and point it to none. That is simply how we append, right? So we're going to do append. Next action we're going to do on the linked list, let me go back to gray. Action 2 is display, which is just iterating through the linked list and printing each of the elements in the linked list. It's pretty straightforward. Third action we're going to do on the linked list today is length. Again, which is just iterating through our linked list and keeping a count. So this is going to be element 0, 1, 2, 3, keeping a count of how many elements there are. So in this linked list we have 1, 2, 3, 4, 5, 6 elements. Keep in mind we don't count the nons, right? Because this is the outside of the linked list is 2. So this is 6 elements. And then the last one, which is the most interesting in my opinion, is called prepend. And he's sort of the opposite of append. Append, we added this node to the end of the linked list, but prepend, we want to add him to the front. The process of doing it is sort of similar to append. It's just first step is to create that node we want to prepend. We create him, and then we find our head node. This is going to have a value of -2, like we said, that's who we want to prepend. So once we find our head node, we break his pointer to the next node and make him point to this node we want to prepend. And then we take the pointer of this new prepended node, the next pointer, and point him to the next guy. So that way we would have gone through all 4 of these actions. Without further ado, let's go ahead and put this explanation we have here. Let's go ahead and put it to code and see what it looks like. As always, we like to use Python, and specifically Python 3 because it's the best language. So I'm gonna call this linked lists. Let's go ahead and make this full screen also. First step is to define our node class, because the node is the building block of the linked list. So let's say node class. Okay, and what does he look like? Class node. Let's go ahead and have the constructor define dunder in it self. Okay, and this is just boilerplate for stuff. And he's gonna have some data, and we're gonna initialize it to none, right? Our node consists of 2 things: the data and the pointer to the next element. Self.data equals data, which is this data you just pass in. If you don't pass in anything, by default it's going to make him none. And then the second element is the next pointer. Okay, so the next pointer by default, let's make him none. So again, we could have done this in here, right? We could have done this, said next also takes him none by default, and then call this next. Okay, this is the exact same thing, but for some reason I think it looks better when it's done like this. So now we're done with our node class. Let's go ahead and now use this building block to create what our linked list is. So now, okay, so our linked list is just simply a combination of nodes, okay, linked nodes. So let's create a constructor dunder init self. This class doesn't take any arguments. However, let's define our head node, kind of like we talked about here. Our head node, the first node. Let's go ahead and define him. To define him, we do something like self.head equals head sounds good. No, I'm just joking. Yeah, so self.head equals node. So that's the first, we have defined this. So let's define our first method or function in the class, which is append, like we said. Without this, we can't build our node. So append is going to take the data we want to append to the linked list. So let's say self. This is standard for every method in a class. You have to have the self and data. Takes in the self and takes in data. Just takes in data. So first step to append, kind of like we said earlier, the first step is to create a new node, right? So how do we create a new node? We just say new node, or any variable name you want, equals node. We use the node class to construct an object, to construct a node object, and then pass in this data. So now at this point we have a node object, and like we said, we're going to iterate through. But first we're going to start at the head of our linked list. So I'm going to initialize a variable called current and set them equal to the head of the linked list. Okay, so now current is at the head of the linked list. So now I'm saying while current dot next, you can say is not none. Okay, this is correct, but I just prefer while current. As long as he's not null, as long as there's something there in the next guy, we're just going to move current to the next guy. Okay, saying as long as this guy is not null, just make current him, just move him to the next guy. So all this does is pretty much we're going through each of these elements to find the last guy that doesn't point to a null. Once we find the last guy that points to a null, that's where we want to append our new node. So then once we get to the end of this, at this point we're at the end of him, right? We're just going to say current dot next. Okay, we're going to change the next pointer to point to the new node we just created. So this is our first function. We're done with our append function, but again it's kind of pointless because we need to visualize what we're doing. So I'm going to go ahead and create our next function, which I'm going to call our display function. Display is not going to take in any input, so just self. He doesn't take in any input, he just displays kind of like just a regular print statement, I guess. Again, as always, we like to start with this guy. Start from the head of the linked list, and then let's iterate. So while we're not at the null element, we're not at none, the last guy, okay, while we still have values, let's print. Who do we want to print? We want to print current, we want to print this element. But remember, cur is just a node, right? And a node has two things, right? It has the data and a pointer. We want to print his data. And then just for aesthetics, let's go ahead and add something just to make it look slightly better. So what I want to add is this arrow right here, just so it looks more like a linked list. So once we print this, once we iterate print this, let's go ahead and move our current to the next. This is literally how you move through the linked list, by moving the current to the left. And then in the end, let's print none, just to represent the last guy. So these two functions are okay for now. Let's go ahead and kind of like create our linked list. I'm just going to call this my list, and he's going to be equal to the class linked list. So he's an object of type of class linked list. Okay, now let's append to him. So kind of like we had in here, let's start with 0, A, 4, 6, 8. Okay, just kind of like we have it here, no 10 and no -2 for now. So my let's move up a little bit. My list dot, let's call it dot append. Okay, what do we want to append, right? We want to append a 0 first. Let me go ahead and run this just to make sure there are no obvious errors. Okay, good. We have the check mark where we have the check mark right here, so no obvious errors. Okay, so we said we're going to append 0 first, then we're going to append, let's see, 0, A, 4, 6, 8. 0, A, 4, 6, 8. And then let's go ahead and display. So my list dot display. Let's just go ahead and display so we can see what our linked list currently looks like. Let's run again. Okay, good. So like I said, we have none here, then we have 0, A, 4, 6. For some reason, we're not seeing the last element. So let's figure that out. So let's go ahead and move our print statement from here down here, and let's see what happens. So now we have 8, but however, again, there's supposed to be a none here, but we don't really care about him because again, he's technically not part of our linked list. It's just how I like to start a linked list. This is the actual linked list, so we're gonna leave it like this for now. So I moved the print statement right here. So now we can visualize this is our linked list. Next step, kind of like I promised you guys, okay, is now we're gonna do the length. We're gonna calculate the length, and the length is actually pretty straightforward. You just start at the head and you iterate till you get to the end. So let's go ahead and create our length. So def length, like just like display, he doesn't take in any inputs, he just wants to show us the length of our linked list. Okay, I'm going to initialize cur like always, which is our current element, and as always we set him to self.head. But I also want to initialize a second variable called count, which is going to count how many elements we have, and I want to initialize him to 0. So at this point we have 0 elements because we're not counting the head, right? The head points to none. Then I'm going to say wow dot next. You see a theme here. As long as there's a next, as long as the next guy is not null, let's increment count. Then once you're done incrementing count, you move current to the next guy. Then once you move into the next guy, just return count. So let's go ahead and print the length of our linked list. Okay, so let's say something like the length is, okay, and what do we want to pass in? So my Okay, let's call the dot length method from our list. Okay, let's go ahead and run this and see. Let's give a space right here. Okay, so yeah, it tells us, hey, the length of this list is 5. Let's go ahead and say, let's append a 10 just cause. Okay, again, we're gonna call our append method and append a 10. It's gonna append into the back of the linked list. Bam, we have 10, the length is now 6. So as I promised also, our last function is our prepend. And just like we kind of described, prepend is appending to the front of the linked list, not append to the end. Okay, so we want to append to the front. All we have to do is find this head node, change his next pointer to point to our new node after we create our new node, and the next pointer of the new node points to the next element. Let's put this to code. Okay, I'm gonna create my next method, prepend. So prepend takes in 2 elements. The first element prepend is gonna take in is, well, technically itself is not an element. You have to put it in every method, so I'm not gonna call that an element. So prepend takes in only 1 element, which is the data you want to prepend. Okay, self is just standard for every method inside the class. So now you have this first step is to create your new node, just like we did in Append. New node is just going to be equal to using the node class, passing the data into it. So now we've created our new node. Let's find self, like we said here. Find the head element. His next pointer should point to this new node we just created. And then the next pointer of the new node should point to the next element that came after head. So let's find the head pointer and break his pointer. So self.head.next. Let's break his next pointer and set it to point to our new node. So at this point, we've set the next pointer of this guy to new node. But at the same time, we also said we want to set the next pointer of our new node. So new node.next. Let's set him to point to the previous guy, which is self.head.next. So we're literally just swapping the next pointers of these 2 guys, and that's it. That's all we gotta do. So let's go ahead and prepend. Let's right here before we display. Let me display my initial linked list first before the last append, and now let's display him again after both the append to the back and the prepend. So my list prepend. Okay, and who do we want to prepend? Let's prepend -2, like we said. So let's run this and see what it looks like. So this is our original list. Okay, this is our new list where we appended 10 and then we prepended -2. So that's it for this video, guys. I hope this code was helpful to kind of show you guys what the node class looks like, what a linked list actually is, and these 4 basic operations: append, display, length, and prepend on a linked list. There's going to be a part 2, and I'll see you in the next one.